Hello everyone, this is Oshini from Cheenta.com. Today we have a very beautiful problem from American Math Competition 8 or AMC 8. It's a very nice math Olympiad for middle school students. This particular problem is from probability theory. However, if you are attending one of our math Olympiad programs, you already know that at the middle school level, probability problems are basically counting problems in disguise. So in this particular video, we will go through certain techniques that you can use to solve problems like this. We will also use something called a complementary counting technique. So look out for that. But at the middle and end of the video, I will also give you some challenge problems. So these problems, you can solve it on your own, put it in the comment section, and I'm sure the best commenter as usual will get a little award from Cheenta, and we can invite you to showcase your solution in our channel. Okay, so let's get started. The question says that a small airplane has 4 rows of seats with 3 seats in each row. So this is how it looks like. You have 1 seat, 2 seats, 3 seats, and you have second row, and then you have 2 more rows. So I can just copy this and paste it here. So you have 4 rows and you have 3 seats in each row. 3 seats in each row. So the second thing that they say is that 8 passengers have boarded the plane. This has happened already and are distributed randomly among the seats. So what does that mean? I'll come to that in a second. But then let's first read the entire problem. It says that a married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So maybe there are 2 seats like this so that the married couple can come and sit there. So what is the probability that 2 such adjacent seats are there in the same row? So let's first understand what is the meaning of distributed randomly. Well, in the terms of probability theory, it means all the choices are of equal probability. Let me explain. First, you have to understand what is it that is happening. Well, 8 people are coming in and they're occupying 8 seats. That is the event. That is the event. So let me describe one event. So, we're trying to get to the bottom of the concept, not only solve this problem so that you learn something from this video. What is one such event? Okay, so one such event can be that row 1, this is row 1, row 2, row 3, row 4, and column 1, column 2, column 3. So maybe one event is row 1, column 1, that is this particular seat is occupied. Row 2, row 1, C3, this is occupied. Row 2, C2 is occupied. Row 2, C3 is occupied. So maybe row 3, C1 is there. And then all the 3 seats in the row 4 are occupied. So row 4, C1, row 4, C2, row 4, C3. So notice how I have completely written down the positions in which the 8 people who have already boarded have taken their seats. This set containing 8 seat numbers is one possibility. One possibility, right? Now, there can be many such possibilities. What distributed randomly means in probability language is that each one of those possibilities have the same probability. Okay, so maybe I'll explain this a little bit more because it's very important that you clearly understand what's going on. In mathematical term, the word probability has a very specific meaning and you have to understand it. What it means is that it assigns a number between 0 and 1. Let's not use the word chance. Let's just think of it absolutely mathematically. This is one possibility, and I want to assign some number P1 to this particular possibility, some number between 0 and 1. 0 meaning it cannot happen at all. 1 meaning this is what will happen. We don't know it cannot happen at all. We don't know this is what will happen. So it's somewhere between 0 and 1. Similarly, we can have another probability or another possibility, which is maybe all the 3 seats are taken. So R1C1, R1C2, R1C3. Then maybe the second row is completely taken. So R2C1, R2C2 and R2C3, and finally the third row first 2 seats are taken. So R3C1 and R3C2. So this is another point, another possibility. So this is what we will do. We will also assign some number to this particular possibility. Let's call that number P2. Maybe this P1 is 0.12. Maybe P2 is 0.15. Some number between 0 and 1. So why are we doing this? We are doing this to give some weights, some probability values to each of those possibilities, each of those cases. Now, the question is, how many such cases will be there? Well, you can count them. You can count the number of cases, which we will do in a moment. Basically, what you have to do is, you have to, from these 12 seats, you have to choose 8 seats, and you have to check in how many ways you can select those 8 seats. That is 12 choose 8. 12 choose 8, which is same as 495. 12 choose 8. There are 495 such possibilities. 495. So there are 495 such possibilities, such cases. So we have assigned all of these numbers P495 to each of these cases. Okay? That is what a probability function does. So what you have to understand is probability is a function. To each of these cases, it assigns a number between 0 and 1. And moreover, another property of the function is this, that if you add up all of them up to 495, if you add up all of them, then all of them adds up to 1. Why? Because 1, in your mind, you can think of it like this. 1 is sure shot case. 1 is everything. 1 means this is going to happen. So one of these 495 cases will happen. So you should add them up to get 1. That's the intuition. Okay. but that's exactly what's happening. So I want you to write this down if you can. So probability is a function. So what is a function? It's an input-output machine which takes input as a case, a possible case, like the 495 cases that we have talked about, and the output is a number between 0 and 1, such that all of them adds up to 1. All the cases, if you add all the numbers, all the outputs, they should add up to 1. That is the crux of the matter. Now, what is the meaning of distributed randomly? What is the meaning of this? It means all of these output numbers, P1, P2, up to P495, all of these output numbers are actually equal. In math lingo, we say they are equally probable or distributed random. So all of them are of equal probability. So here is a challenge. If P1, P2 up to P495, the 495 output numbers, if they add up to 1, and if all of them are equal, then what is the value of each of these numbers? Can you tell this to me in the comment section? This is challenge 1. If all of them are equal, in fact, then what is the value of each of them? So, in fact, I do not like the word probability a lot because it has this connotation of chances. Mathematics is very precise science. There is nothing related to chance here. So what I usually do is I think of it as weights. Instead of the word probability, I use the word weights. It removes that language thing that, okay, this is something mysterious, something related to probability. No, it is not. It's just a function. You take a case, you assign a number to that case. Take another case, assign a number to that case. And you add them all up to get 1. That's it. It's very simple. Okay. Actually, there is a little bit more, but since we are talking about middle school students, I'm not getting more deeper. But this is the thing, what's happening. All right. So now that we have a clear understanding of this part, which is very important conceptually speaking, we want to know, out of these 495 cases, in how many cases the married couple will be able to seat in the 2 adjacent seats. Okay, so how many of the 495 cases are favorable? How many of the 495 cases are favorable? So what we are going to do is we are going to use something called complementary counting. Complementary counting, okay? This is very important. Favorable means in how many of those cases 2 adjacent seats in a row will be empty. We can check case by case and just take the ones which are favorable. And for a computer to do it, it's very easy. Maybe you can write a little algorithm, check each of those cases, and check the row number and column number and check if it is favorable or not. But we will use complementary counting to actually do it more quickly. So complementary counting is in how many cases it won't work. So let me draw this picture one more time and I immediately will see what I mean. So I have this 12 seats like this. So let's take the case 1. Case 1 is all the middle seats are taken. If all the middle seats are taken, no matter how you put the remaining 4 people, doesn't matter, you will not have 2 adjacent seats if all middle seats are taken. So case 1, all middle seats are taken. So then how many ways to select all the middle seats? Well, that's 4 choose 4 times you have to select remaining 4 seats from these 8 seats. So that's times 8 choose 4. That's case 1. Now the second case, case 2. This one is interesting. Exactly 1 middle seat is empty. Okay? Exactly 1 middle seat is empty. So suppose these 3 middle seats are taken and this one is empty. Okay? Remember, we are counting the complementary case. So we don't want the married couple to be able to sit together, right? So since this middle seat is taken, we must fill up these 2 seats. Otherwise, the married couple would be able to sit together. So now we see that, okay, if a middle seat is empty, then 2 of its adjacent seats should be taken in order to prevent the married couple to sit together. So 5 of these seats are now taken. We have to have 3 more seats. So these 3 more seats will be taken from 1, 2, 3, 4, 5, 6. From these 6 seats, we have to select 3 more seats to count that case. So 4 choose 1 is the number of ways to select the empty seat from this middle 4 seats. And from remaining 6 seats, we select 3 of them to make the other 3 people sit down. So again, in case 2, we do not allow the married couples to sit together. Similarly, case 3, exactly 2 middle seats are taken. So let me illustrate that a little bit. Suppose this one is taken and this one is taken. So this is empty and this is empty. Again, we want to prevent the married couple to sit together. So we must make sure that these 2 are occupied and these 2 are occupied. So 6 of them are done. 6 people have been already seated like this. So remaining 2 people must sit. In these 4 seats. So that can happen in 4 choose 2 ways. And of course, I have to choose the 2 seats which will be occupied in the middle row, middle column. So that's 4 choose 2 ways. So I have case 4 and case 5. Case 5 means all middle seats are empty. All middle seats are empty. If all middle seats are empty, then all the 8 people should be seated like this to prevent the married couple to sit together. So that's only one way possible. You just keep all the middle seats empty and make the other people sit on the 2 columns. Case 4 is exactly 3 middle seats are taken. So that can be done in 4 choose 3 ways. Take the 3 middle seats out of 4 of them. And so let's say, okay, this one is 3 middle seats are empty. Exactly 3 middle seats are empty. So you can choose the 3 middle seats which are empty and you can make, so maybe it's like this. So you have you have these 3 middle seats are empty. So these 3 middle seats are empty. 1, 2, 3. These 3 are empty. This one has someone. So now I have accounted for 7 people, and the remaining 1 people should be seated in one of these 2 seats. So to choose one. So these 5 cases actually tell you all the number of ways the married couple cannot sit together. So what you can do is, you can now divide all the favorable cases. That is, from 495, you should delete all the unfavorable cases. So these are the numbers. So this is, I think, 80. This is 70. This is 36. This is 8. This is 1. Okay. So you have 80 plus 70 plus 36 plus 8 plus 1. So if you do that and you subtract it, and then if you divide by the total number of cases, this is the total cases. This is the favorable cases, unfavorable cases. These are the cases where the married couple cannot sit together. And if you delete it from all the cases, then this is all the favorable cases where the married couple can sit together. So if you do this ratio, you will get the final answer. So can you do this calculation? This is the challenge 2. Challenge 2. Can you do the calculation and tell me the final ratio of this probability? Okay. I hope you learned something from here. It's not just about the problem. At Cheenta, we believe that you start with a problem and then you go deep into some concept. And in this particular problem, we learned 2 things. What is the meaning of random distribution? And second, in this particular context, what is the meaning of the word probability? And thirdly, well, we learned the complementary counting method. All right. Thank you for joining us today. If you want, if you're interested in outstanding programs in mathematical sciences, Mathematical Olympiads, Physics Olympiad, Computer Science Olympiad, check the link in the description. We are very passionate about these subjects and we have been doing this for quite some time. So I think you'll enjoy the community. All right. Take care. Bye.